We're going to call the await method, and they will remain blocked as long as this count of 3 doesn't come down to 0. Like a hilltop, 4 friends are trying to climb up. So one of them have climbed up and they have reached their common destination, and the others are on way. So each one of them reaches and waits for the other friends. So it might seem little bit similar to what we have discussed. This is also something similar to CountDownLatch, but when you're calling the await method, right, it shows that you're waiting for other worker threads, and you cannot really proceed with your rest of the execution because you're waiting, means you are in a block state, right? So once everyone is done, all the parties have called the await and reach that common checkpoint. Hi everyone, welcome to my channel Code with Ease by Varsha. So we have been doing a playlist on multi-threading in Java, and these are the questions which we have covered so far. Along with that, we were also doing another playlist on threads coding questions, and again these are the coding questions that we have covered so far. So if you have been following our playlist for quite some time, you might have noticed that we are talking about synchronization primitives. So we talked about semaphores, we talked about reentrant lock. We are going to cover 2 more classes from the Java util.concurrent package, which is CyclicBarrier and CountDownLatch. Along the video, we are going to see what are the different real-world use cases of that as well, and why it is so important to know about these 2 synchronization constructs. So without further ado, let's begin. With the introduction, these are the classes which are part of Java util.concurrent package, and we know that they are used to coordinate the execution of multiple threads. Now, what is CountDownLatch? It consists of 2 words, countdown and latch. Let's try to understand it one by one. What is this used for? It helps threads to wait until certain tasks and other threads are finished. So it will allow the other threads to proceed only when the set of threads which are actually doing the work are completed. So you can think of it like there are 4 threads that are doing some work. Latch can be thought of it like a barrier, a gate. So there's a latch which is over here. It acts as a guard, safekeeper, whatever. It acts as a safeguard or a gate, whatever. So here's a barrier. So this is the barrier that we have. And then there are more threads which are coming in. While these 4 threads are in progress, you cannot allow other threads. The other threads can be allowed only when the gate is open. So when these 4 threads are doing the work, the gate is locked. So what it is trying to do is, if a set of operations are being performed by the other threads, then the new threads need to wait until they are done. Once they are done, only then this barrier will open, this latch will open, and the new threads can come pouring in and start doing the rest of the work. So how this functions is, it starts with some initial count. So in this case, I gave 4. Okay, let's say it starts with an initial count of 4, and that is the number of times the threads need to count down before the waiting threads are allowed to proceed. Who are the waiting threads? The waiting threads, and these are the current ongoing threads. So once each of these threads among this set of 4 are done, they will say there's a method called countdown. So it is like, I am done, one thread is done, it will say I'm done. Then second thread, it will say like that, it will say, keep on saying until the count equals to 4. I mean, it is something like it gets decremented, 4, then 3, 2, 1, right? So this is what the significance of this method is, and hence the name CountDownLatch. So we understood why the latch is being used, and now we are trying to understand what is the countdown is being used for. So countdown is called by threads to signal that this operation, I am done, I'm finished with the work. So I'm calling this method. It will decrease the internal count by 1. So if I started with 4, then I'll go to 3, then 2, then 1, and finally it comes to 0. Like I said, what is the latch is going to be used for? So the threads calling await. So like I said again, so now there are the 4 threads, and these were the 2 waiting threads, and we had the latch in between. The threads which are waiting outside, they are going to call the await because they are waiting. So when you have the latch, this latch is trying to block them until the count reaches 0. Just now which I showed, that it will be 4, 3, 2, 1 and 0. Started with 4, ending at 0. Until it reaches 0, this latch is going to block it. Latch is released once the count is 0, and then the waiting threads are released, and this latch is going to open, and these threads are going to proceed with their execution. So this is a one-shot mechanism, which means once the latch's count is back to 0, you cannot reset it. Okay, so this is a one-shot process. The count cannot be changed or reset. So now let's see the working of this. So if I talk in terms of code, initial count we have given as 3. The number of times, how many times the countdown method needs to be invoked before the latch is released. Now there will be a try block inside which we will call the latch object dot await. So the main thread, the thread which is blocked until the latch count reaches 0. So all the threads that need to wait for certain tasks to complete, will be calling this await method. Okay. So now we understood that it starts with the initial count of 3. The ones who are waiting are going to call the await method. Like in this case, the main thread is going to be waiting. They are going to call the await method, and they will remain blocked as long as this count of 3 doesn't come down to 0. And for each thread, each working thread, whoever is working, they will keep on doing the work, and they'll call the countdown once the work is done. As a result of which, the total count which we had, 3, is going to slowly decrement. So if you see the point to be noted over here is the countdown must be invoked the same number of times as the initial count. We already covered that. And we know that when the count reaches 0, latch is released and the waiting threads who were calling the await method are now released. They're unblocked. This is the entire code for this. So what we did is we took a validator, like some validation, some check is happening by 3 threads. Validator 1, 2, 3. We initialized it with 3 and there are 3 working threads to denote that. And we started the working. The main thread will wait until the latch count is coming to 0. Once they are done, finally we are going to print that the validation tasks have completed. So inside each validator, this class that we have, inside this validator is what we are going to call the countdown method. So once each validator threads are done, they are going to call the countdown method. So this is what we are getting from the output. First, validator 3 is performing, 3, 2, 1 are performing. Once they are performing, we have also added some sleep. And then once they're done, then we will say that they have completed validation. Finally, it comes into this try block where it's out that all the tasks have completed. So as long as these validator threads were running, the main thread was waiting because the latch count had not come to 0. Because it was waiting, so we couldn't, of course, print the sysout. Once it is done, once it is done is when we could print the sysout, that validation tasks are completed. So this is very simple example of a data validation check that we are trying to do, where we're trying to say that if you have a certain condition to be met, like some checks to be done, some initial health check kind of a thing that you need to do beforehand, and you want that to finish first and then proceed with your original flow, or the rest of the flow, this countdown latch plays a very big role over here. Why it plays a big role? Because of the barrier, the concept of latch or the barrier that it has. Because of that, it plays a big role in trying to stop the rest of the execution, not stop, pause or block the execution so that the actual initialization wala task or the actual initial health checks tasks are completed. So if we talk about the use cases, like we said, the threads need to wait for certain tasks to finish before proceeding. So parallel processing where you have multiple worker threads and you want those to do some computations, and the main thread need to wait until the multiple worker threads are done with the computation, and then at the end you want to aggregate or consolidate whatever results you got from these worker threads. So you can think of that use case also. It's very important, like at the end you want to consolidate the results of whatever you have got so far, and before the worker threads are done with the computation, you cannot really consolidate the result. Similarly, when a fixed number of tasks need to be executed concurrently. Similarly, if you want to wait for certain external events to occur before proceeding with execution of a program, then also this comes in handy. When you're trying to shut down, it can be used to wait until all the dependent resources are released. Like we use this try with resources. Earlier we used the finally block. So all that checkup or all that cleanup activities can be done before you try to shut down a certain service. So all of these use cases are something in which CountDownLatch as a synchronization construct comes in really handy and should be considered. Now moving on to the second primitive, which is CyclicBarrier. Again, 2 parts, CyclicBarrier. And barrier or latch or gate is something synonymous. So we have already discussed about that. So now the question comes to like, why is it cyclic? Okay, so let's discuss about it. Here what it does, it allows a set of threads to wait for each other to reach a common barrier point. So again, I would try to draw something like this. This is the common barrier point. You have, again, I'm giving the example of 4 threads, 1, 2, 3, 4. So all these threads, 1, 2, 3, 4, you want them to finish one by one and come to this common barrier point and wait for the others to finish. You can think of it like a hilltop. 4 friends are trying to climb up. So one of them have climbed up and they have reached their common destination and the others are on way. So each one of them reaches and waits for the other friends. So it might seem little bit similar to what we have discussed. This is also something similar to CountDownLatch, but we'll see gradually what is the difference. Why is it called cyclic? Because this particular barrier can be used again after the threads are released. So it's something like all your friends come down and then you again try to climb up. Unlike CountDownLatch, CyclicBarrier can be reset and it can be used again. So that is why it is like a cyclic rotation. In case of CountDownLatch, it was something like you had to do it as a one-shot process only. You cannot reset the latch or the countdown, the value of that. Each thread calls the await method, which causes it to wait until all parties have arrived at the barrier. Over here, the await method that is being called is now being called by the participating or the worker threads, like the friends who are now in progress in execution. They itself will call the await method and they will wait until all the threads have reached to that common destination, the common place that they want to go, or the common point that they want to reach. When all parties call await or the timeout expires, the barrier triggers and all threads are released at once. What does it mean? It means that when all the threads are finished and each of them have called the await method and now they have reached that hilltop, let's say, or when the timeout expires. So let's say you had 1 hour to climb and it's already past an hour, and that is signifying that the timeout expired. So under these two conditions, either the timeout expired or all of you have already reached the hilltop, then the barrier triggers, like the barrier is released, and now all the threads are released. So now nobody is blocking for anyone, like nobody is waiting for anyone. Earlier 1 2 3 4, one of them, whoever reached, was blocked. Why it was blocked? Because it was waiting for the friend or the other threads to complete. So how does it work? If we talk in terms of code, similar to the initialization of CountDownLatch, we are initializing the number of parties. That here the count is different. Here it's like the threads that must wait at the barrier, and in this, each thread that synchronizes with others called the wait. Over there it was the other threads. In case of CountDownLatch, we had the outside parties waiting by calling the await method. Here the subtle difference is the participating threads itself are calling the await method to symbolize that they are waiting. They have reached the destination and they are waiting. Thread calling this method will wait until all parties have reached this point, unless you have an interrupted exception or a broken barrier exception when the barrier is going to release and this entire scheme is no more going to be valid. Otherwise, they're all going to wait for the other worker threads to complete. Elaborate more on this code example. So like we were giving the example of climbing the hilltop. So we have a hiker class. So we have 4 hikers over there. And here the hiker class represents each hiker. We have 4 of them. Now what is happening inside the hiker class? So one of them started hiking and we have a module, just a simulation of waiting for some 5 seconds. So once it does that, it has reached the hilltop. Then it is calling the await. Once it calls the await, it calls the await, which signifies that it is waiting for other hikers to reach that checkpoint. And once all the 4 hikers have called the await method, like we have seen that all hikers have reached the checkpoint, hence it will print that it is completed, or it continues hiking to the next breakpoint, let's say, or maybe it is done with the hiking. We can keep this sys out to whatever we want to, but the point we are trying to say, it starts the hiking. Once it reaches the hilltop, it is calling the await because it still doesn't know whether all of them are done or not. So it will say I'm waiting for others. So what do we get in the output is something like this. All 4 started hiking, and once each of them reached the checkpoint, they're going to print that they have reached. So whenever they're trying to reach a checkpoint, each of them calls the await. So internally, some sort of counter is being maintained. So whenever each of them reach a checkpoint, they're going to call the await. Once all the hikers have called the await method, then it is going to come to the next sysout. So try to understand this. When you call await, you are blocked. Technically, you cannot really proceed with your execution. So the important takeaway is you're going to have this initialization denoting how many parties are involved. Secondly, when you're calling the await method, right, it shows that you're waiting for other worker threads and you cannot really proceed with your rest of the execution because you're waiting, means you are in a block state, right? So once everyone is done, all the parties have called the await and reached that common checkpoint is when you are released. So then you're free to do your own rest of the execution basically. So this is the important thing that we have to understand in case of cyclic barrier. So let's talk about the use cases. So as we understand, cyclic barriers are used when threads repeatedly count down to a particular point. So all of them are trying to go to this particular point and they are doing it repeatedly, like every thread is doing that. As a result of which, how is it useful that when multiple threads are working on different parts of a program and they need to wait for each other to combine the results. Now you might think this is similar to what we were talking about in parallel processing. Over there, the participating threads were not waiting for each other. The threads which were outside were actually waiting for these 4 threads to complete. This was the logic of CountDownLatch. In this, these 4 threads are self-sufficient. These 4 threads are self-sufficient. They, once they are done with the task, are waiting for others, so they themselves can combine the results before they can continue. It can be used to coordinate the progress of threads at specific stages of batch processing. So like I said, here there is 4 threads. It can be 40 threads or 400 threads or thousands of threads. Each of them will keep a track, or each of them is like tracking the progress of the other worker threads that is being done in case of batch processing, and then collate the results accordingly. In case of multiplayer gaming servers, for processing of concurrent game events or progression of all players to the next game phase. So these are the different use cases that we can have. These are different use cases of cyclic barrier which we can have. The most important thing is here the participating threads are waiting for each other to complete, and then they can combine the results of what they got. In case of countdown latch, there was no concept of the participating threads being waiting for each other. It was the outside threads, so the outside parties that were waiting. So what's the difference between both? So when do we need countdown latch? When the threads need to wait for other operations to complete, like the 4 threads versus 2 threads waiting outside. And here the fixed number of threads are synchronizing in a cyclic manner and they are waiting for each other to complete, right? Next is the resetting. Countdown latch, it's a one-shot event. Count cannot be reset back to 0, but since, as the name suggests, it is cyclic, the barrier opens, it reopens, gets closed again. So you can reuse the entire, so the threads which are participating in the cyclic barrier can again do the same thing. They can again they can again initialize the object and go back to the same logic of trying to reach the same checkpoint. Blocking behavior, await blocks the calling thread until the count reaches 0. Here await blocks the calling thread until all parties have reached the barrier point. So the technical difference is over there we had a concept of count which needs to come to 0 and then the barrier will open. And here the participating threads need to reach that particular barrier point or the checkpoint, and only then the barrier gets released. Use cases like we have discussed where threads need to wait for certain tasks to finish before proceeding, and here multiple threads work on different parts and they come together, reach the checkpoint and try to synchronize the progress at particular points. The point is at specific points because it is a cyclic barrier. So you can think of it like you have climbed checkpoint 1, again you have climbed checkpoint 2, again you have climbed checkpoint 3. So there are multiple points. So in case of complex distributed problems, you might have different checkpoints and you may want to repeat this process again and again. So when to use either of them? If you need one-shot synchronization, that you have the health check example like I gave, you want the initialization checks to be done first and then you proceed with the rest of the execution, you're good to go with the countdown latch. But if I talk about that batch processing where you might have multiple stages in which you want to synchronize the result, then you have to ideally go with cyclic barrier. Number of threads waiting for the operations to complete can vary. This is the important point which we were trying to say, that over there in case of countdown latch it was 4 versus 2 threads were outside and 4 were involved. So it can be through 2 threads waiting, it can be more than 2 threads also. But here the ones who are actually calling the await method is fixed. Within that particular 4 threads only they were synchronizing the progress and waiting for each other to complete. The reuse point, again you cannot reuse this, but in case of this you can reuse it. So cyclic barrier and countdown latch, like we discussed, they are used to coordinate the execution of multiple threads at certain points. But if you have watched the semaphore video of mine, which I have in this particular playlist also, do check it out. Semaphore's nature is the limiting nature, that it has the number of limits or the permits, where it tries to control the access, that I want only X number of threads to enter inside my gate, and it limits that number of threads to access the resource. So I just want X number of threads to access the shared resource at a given point in time. So the nature or the purpose of work is different. Here it is more of a controlling nature, that they want to set a upper limit or a limit on how many threads can access the shared resource at a time. But this is not the case in case of countdown latch or cyclic barrier. This is more of a collaborative approach is what I like to think of, where you want the threads to do the work together, coordinate, consolidate the results together. And that is how you want them to coordinate the execution. But semaphore is like the strict person who just want to do the controlling or the safeguarding of resources by doing the limiting, by setting the number of permits. Is it possible to dynamically adjust the number of threads which is involved in the countdown latch or cyclic barrier after it has been initialized? It is not possible because both are designed to work with a fixed number of threads. We have already seen the constructor of that we are taking in, we are supplying the number of threads at the very beginning. If you want to adjust the threads dynamically, you have to reinitialize it with a new number of threads. In between, dynamically in the runtime, you cannot really change how many threads are being involved in neither of them. So what are the potential pitfalls to avoid when using cyclic barrier and countdown latches? To avoid the deadlocks, we do not want the threads, they are going to be waiting at some point, but we don't want them to wait indefinitely. To avoid that, we have to see that the threads are getting released or they're reaching the barrier point. This usually happens when you misuse the methods, that you don't call the countdown or you're not calling the await at the right point where you need to call. So like we said in countdown latch, you have to call the countdown that same number of times. Let's say in one of the threads, you forget to call the countdown. So it is going to lead to that infinite loop kind of a situation where the count never gets reset back to 0. not reusing mechanisms when applicable. So cyclic barrier can be reused again and again, and if there are multiple points required, we can use the cyclic barrier. And also the exception handling needs to be done properly. So these are some of the things to keep in mind when you're using both this synchronization construct. Um, yeah, so with that, we are going to wrap up today's session on CountDownLatch and CyclicBarrier. Thank you so much for watching this video. Hope you guys have got some value out of it in terms of threads and concurrency. Do follow the playlist for more such questions like this. And we have tried to cover from scratch all the concepts. So even if you're a beginner, it's going to be important for you to start all the videos from scratch. And thank you again for watching. Do like this video and subscribe to the channel if you haven't already. Thank you so much.